In today's video, we're going to be going over a significance test for a mean. We're just going over a second worksheet of practice, going through the four-step process now fully of state plan do conclude. I do not have thermometers for everybody to take their own temperature, so we're just going to use some old class data. We have a simple random sample of high school students with a mean of 98.237 degrees Fahrenheit. Definitely add some context in there. We've got a standard deviation of 0.822 and a sample size of 32. I want you to go through state plan do conclude. Pause the video and work it out. You know what to do. Fill out through all the way to the bottom. I know that this part right here might take you a little bit more thought, but please, please, please try to do it before you unpause the video, and then I will go over the results. Okay, double checking you paused. Let's move on. So I've got my state plan do conclude filled in here. For state, the parameter, remember mu is our parameter now. It is the true mean body temperature for all high school students. The statistic, that is our X bar, that is 98.237. Our hypotheses. So the null hypothesis is that the mean is 98.6. And so what that's coming for is the problem itself, which tells us that a normal body temperature is 98.6 degrees. So that's what we're testing, whether or not this is true. Now, the alternative, and I hope you saw this, is that mu is not equal to 98.6. So remember that when we're doing these problems, and we are trying to find convincing evidence that it is simply different. Not that it is more, not that it is less, but just that it is different. That is the not equals to. And so that makes this a two-tailed test. And our significance level is 0.05. All right, for the plan, naming the procedure, we're going to do a one sample t-test for mu. And we've got our general formula, our specific formula, and then our plugged in formula. I got a t-score of negative 2.50. Notice that I have my picture as well. I'm using the standardized curve for t. So this is really the best curve to draw. So I would try to get in the habit of drawing the standardized curve when we do t-scores, as opposed to it filled in with your your statistics. Use the test statistic instead. We've got our t-statistic, we use that to find the p-value, and then we take our p-value and multiply by 2 because this is a two-tailed test. Now, to find the p-value, remember there's two ways to do it. The first way is we could use the table. So for the table here, my sample size is 32, so my degrees of freedom will be 31, and then test statistic is negative 2.5. So I'm going to go over to that. So now, unfortunately, all we have is 30. So we're going to go with 30 because we don't have 31. And I'm going to go over to 2.5, which is probably closer to 2.457. And if I go up, that's 0.01 as my tail probability. But remember, that's not ideal. While 0.01, I mean, this would technically round to 0.0. This would technically round to 0.01, right? But 0.009 is more accurate. So using the calculator just gives us the most accurate response. But if you do use the table, that won't be wrong, as long as you remember to multiply it by 2, because this is a two-tailed test. And then that brings us to the conclusion. Remember that our conclusions for hypothesis testing has two parts. The first part, we need to interpret the p-value. And my interpretation says, assuming the null is true, which is that mu equals 98.6, there is a 0.018 probability of getting an X bar of 98.237 or higher purely by chance. Then it comes to our decision. So are we going to reject or fail to reject? Because 0.018 is less than 0.05, we reject the null. Ooh. We do find convincing evidence that the mean body temperature is different than the doctor's claim. Again, here I'm using the word different. I'm not saying is, more than or less than, because this is a two-tailed test. All right. If you have any questions about this process, you can ask me in class. But I'm going to move on to this next section. And if you did not get to this next section, please pause and try it on your own. Okay, so this part says another class did the same activity with these results. X bar is 97.9, standard deviation is 1.6, and sample size is 30. Use the t-test on the calculator to find the p-value. All right, so we have three different significance levels, and we want to determine whether we're going to reject the null at all three. So on the calculator, I'm going to use the t-test. So I'm going to stat over to tests and down to number 2, which is t-test. For this one, I am going to use the stats, so input stats rather than input data. All right, the mu sub 0 is going to be 98.6 for this. So I'm going to type in 98.6. X bar for this other class of sample is 97.9. The standard deviation is 1.6, and the sample size is 30. Then it asks you whether you want to do mu is not equal to the null, less than the null, or greater than the null. This is a two-sided test, so we will say not equal to, and then we are going to calculate. When I do this, I find that their p-value is 0.0187. So let's determine whether we reject the null at all of these different significance levels. So if our significance level is 0.1, this p-value is less than 0.1, so yes, we do reject. All right, for the next one, if the significance level is 0.05, 0.0187 is less than 0.05, so we reject. And the last one, comparing our significance level to the p-value, 0.0187 is greater than 0.01, so we fail to reject. All right. Now we're going to, in question 2, use the t-interval on the calculator to find the following confidence intervals. So with the same results, I'm going to go back to stat, over to tests, and I'm going to go down to option 8, which is t-interval. The X bar is 97.9, standard deviation is 1.6, and N is 30. My C level for the first one, we're going to do 90%. So I'm going to type in 0.90, enter, and calculate. I am given the confidence interval 97.404 to 98.396. Now it says reject the null question mark. Would I, based on this confidence interval, choose to reject the null? Okay, let me remind you, the null hypothesis states that mu is equal to 98.6. Compare this null hypothesis to the confidence interval. Is the null value in the confidence interval? Is 98.6 somewhere in that interval? No, 98.6 would be out here. So it is not very likely that this is true based on this confidence interval, since it is not within the interval. Therefore, I would choose to reject the null. Okay, so I want you to see what's happening here. With the confidence interval, you feel confident inside of that interval. So if anything is outside of that interval, I would say it is unlikely to occur. Therefore, in the terms of hypothesis testing, I would reject that null. Let's try 95%. So in my calculator, I'm going to go back to stat, over to tests, and down to option 2. I'm going to leave pretty much everything the same except, not tests. Over to tests, but down to option 8, T interval. I'm going to leave everything the same except for my confidence level. I'm going to change to 0.95 and calculate. And now I get 97.303 to 98.497. Now remember that confidence intervals, the more confident you are, the wider your interval gets. So our interval has gotten wider, but hasn't gotten wider enough that it now includes the null value. Is 98.6 inside this confidence interval? No. So we choose to reject the null. All right, now let's try 99%. So we're going to go one more time, stat, over to tests, and down to T interval, which is option 8. And then I'm going to go all the way down to the confidence level and change it to 0.99 and calculate. Now my confidence interval is 97.095 to 98.705. And this time, my null value is inside of the confidence interval. So I do not reject the null because it is a possible, it's a possible value given the confidence interval we have. So what connections do you notice between the answers to number 1 and number 2? Well, if you look at the first one at the significance level of 0.1, we chose to reject the null. And at the confidence level of 90%, we chose to reject the null. At a significance level of 0.05, we rejected the null. And then at 95%, we also rejected the null. Lastly, at a significance level of 0.01, we failed to reject. And at a confidence level of 99%, we failed to reject. Now, how do those relate to each other? Think about the significance level and the confidence level. Well, a 10% significance level is the same as a 90% confidence level. So when we are testing whether we reject or fail to reject, remember that with hypothesis testing, we're looking at this as a normal distribution. And if I'm looking at a significance level of 10%, that means it has to be in the lower or upper 10% of data. So this would be 10%. Now, let's think about a confidence interval of 90%. That means I'm finding the middle 90%. So inside would be 90%. And if you notice, put those two together and you have the whole curve. That 10% on an end versus the 90% in the middle. This 10% here, right? Technically it's 5% if it's a two-sided test. I'm sorry, because you would divide it by 2. I forgot to divide. There we go. And it's going to be the same with all of these, right? 95%, you've got 5% left over for the tails. 99%, you have 1% left over for the tails. So there is a connection, and then this connection is that the decision of whether or not to reject the null is the same using the confidence interval or a significance test. Now, this only does work for a two-sided test because if you have just a one-sided test, right, here's my curve. If I have just a one-sided test, then I don't have a middle. I have from here over, right? And the confidence intervals, those are the middle 90%, middle 95%. So it has to be two-tailed in order for them to be linked together. Otherwise, it doesn't make up the whole curve. All right, moving on to our important ideas for today. We've got first the 4-step process: state, plan, do, conclude. You're going to state the parameter and your hypotheses, the statistic, and the significance level. Then when you plan, you are going to name the procedure and check your 3 conditions. The first one is random. The second one is 10%. The third one is normal or large sample. Remember that random is so that we can generalize. 10% is so that we can sample without replacement. And normal is so that we can use the normal distribution to find our p-value. For do, we have our general specific formulas. We need to find the test statistic and the p-value. I also want to add in here that we want to draw our picture. And lastly, conclude. Interpret your p-value first, and then write the decision about your conclusion about the alternative. Do you reject or fail to reject, depending on whether or not you find convincing evidence for the alternative? Remember to conclude in context of the problem. All right, and then the last part, confidence interval and two-sided tests. How do they relate? If the null value is in the interval, in the confidence interval, then the null value is plausible, and so therefore we would fail to reject the null. If the null value is not in the interval, I just want to make sure this looks a lot like an O, not an A, then that value is not plausible, and we would choose to reject the null. And lastly, a C% confidence interval will make the same decision as a two-sided significance test. Remember, it has to be two-sided, where your alpha is equal to 1 minus the significance or the confidence level. For example, 0.05 as alpha is equal to 1 minus 0.95 as a C%. And so therefore the 95% is related to a significance level of 0.05. All right, use what we've learned today to finish this Check Your Understanding. Make sure you've done the other Check Your Understanding for today's lessons as well. And we will continue tomorrow with 2 sample tests.